integral from group to heat convection. So our objective for the experiment is to determine the forced convection heat transfer rate and steady state of fin plate and flat plate when the velocity is varied. The second is to determine the feed effectiveness of the fin plate and flat plate for the forced convection. So let me first introduce our test rig. First is we switch on the main switch and then we set the constant variable, which is the heater controller, to 50 degree, and then we will adjust our fan speed to 0.2 to 1.0, and we will test it by using the anemometer and get the result from the anemometer ports. After we have set the manipulator variable, our responding variable will be T1 and T2. So after we have done for the flat plate, we will change it to the fin plates to get our heat transfer rate.
Okay, for the result for flat plate, we can see that this is the table for temperature flat plate taken for T1 and T2 at different velocity from 0.2, 0.4, 6, 0.8 and 1.0 meter per second. Until the steady state occur, which is approximately 1% of error occur to the previous temperature. And this is the table of heat transfer rates for 0.1 and 0.2 at different fan speed for flat plate. Same goes to fin plate also. So, for the fin effectiveness, we can see that at 0.1 and 0.2, there is decreasing from 0.2 until 1.0, but at 0.4 there is optimum for fin effectiveness. From the graph plot for flat plate, the rate of heat transfer is keeping increasing for 0.1 and 0.2 with an increasing of fan speed from 0.2 meter per second to 1.0 meter per second. Based on this information, we found out that fan is act as a force that increase the rate of heat conversion that occur inside the duct. And for heat transfer rate versus fan speed fin plate, same goes to the flat plate. The rate of heat transfer for 0.1 and 0.2 is increasing with fan speed from 0.2 meter per second until 1 meter per second. For comparing between flat plate and fin plate, between heat transfer and fan speed, the rate of heat transfer for fin plate is higher than flat plate because fins enhance heat transfer from a surface by exposing a larger surface area to convection.
We will do an analysis on 0.2 meter per second velocity fan speed at temperature 2 for the flat plate and the fin plate. As we can see here, the temperature of the fin plate is always higher than the flat plate because the fin plate has the higher surface area exposed to heat source than the flat plate. This indicates that the fin plate has higher rate of heat transfer than the flat plate. For the next graph, we will do the analysis for the fin effectiveness of fin plate against the fan speeds. As we can notice here, the highest fin effectiveness of the fin plate occur at 0.4 meter per second. However, the fin effectiveness is not affected by the fan speed instead of the surface geometry. From the data, we can note that using the fin plate will enhance heat transfer rate than the no fin plate. This is basically our DAISY lab layout to collect the data. For the analog input, we collect two data, which is temperature 1 and temperature 2. And then from the temperature, we refer to the table F15 to collect the thermal conductivity, Prandtl number, and the kinematic viscosity to calculate the Reynolds number, Nusselt number, heat transfer coefficients, and later heat transfer rates. Same goes to the temperature 2 data. We do the same steps as temperature 1. and then later we get the final heat transfer rate for temperature 2.
Okay, for the part of for the discussion. Okay, for the discussion about heat transfer rate for the fin plate and flat plate. Okay, for the graph, it show that fin plate are higher than flat plate. This because fin plate is more higher, larger of exposed area to the airflow rather than flat plate. The question that being focused during the experiment, first we always check the wind velocity to make sure the airflow is constant. Okay, second is before run the experiment, trial run being test first to make sure the test rig is ready and good condition before taking any reading. For the conclusion at the end of the experiment, the forced convection transfer rate at steady state of flat plate and fin plate when velocity is varied and can be determined. For the second, the fin effectiveness also can be determined at the end of experiment, and our experiment is successfully conducted. Okay, thank you.